This is one of my favorite bootstrap topics and lessons to do with the students. One of the other videos was on advanced visualizations, but we're going to go a little bit further now into the coding and use piecewise conditional functions. Sometimes we want to write functions that are going to do different things based on the different conditions we want to give it. Why in the world do we need piecewise functions? Well, so far, the graphs we've created have been scatter plots with uniform dots on them, but then we added in an image scatter plots, and we were able to do those custom images with a dot, making that circle change based on the size of the age using a helper function, or putting in some text using the text function. We could put the species name, but maybe we want to explore something like, let's make the dots a different color for each species, or maybe we want to use a different shape, whether it's fixed or not fixed, and have squares and circles instead. So we need a piecewise function to do that. What does it mean by piecewise function? Well, the function's going to have more than one piece, and it's called conditional also because each piece is based on a condition. If it meets this condition, do this. Each piece has a condition, and then if not, go to the next line of code, and if this condition is met, then do this. So they're called piecewise. And if you've taught any algebra or math, you've seen graphs where if x is between here and here, then the graph does this. But if x is between here and there, it does something different. That's also called a piecewise graph. So let's start with species dots like the students would and take a look at it. They just kind of look at this and say, ooh, what do we notice and wonder? Students will begin to notice the ifs and the else ifs and the extra ins that are in there. If species is dog, what are we going to do? So what does the function produce for dog row? If I look at the example, I see, oh, if I'm going to feed it a dog row, it's going to make me a solid black square. But what we're going to get if I feed it a cat row, it's going to produce a solid orange square, etc. For, well, rabbit's different, lizard. I am looking at the function and I see each piece has a different condition. Each species has a different condition and a different colored square. So the pirate will go down, pull in a row and say, if species is dog, I'm going to do this. I don't need to look at anything else. But if it's not dog, then it's going to go to the next line of code and check species and so on down the list. So we want to use this to strengthen our analysis. And so let's look at that image scatter plot. Look at the difference now. Woohoo, I no longer have those uniform dots. I can see that species right on the graph. And if you were looking at the advanced visualizations video, you saw that we could put the words on there, but sometimes, tarantula, that gets very long and difficult. They can all squish together, hard to read. Now you could just see those dots in color. There's those black squares that the dogs were. There's those colors that the other animals were. It's very clearly to see as soon as you look at it, I see that those heavy animals are those dogs. Maybe I might want to look at dogs separately. I see a lot of those dogs are taking longer to be adopted as well because the weeks is up. I have 3 variables on this graph showing by using the different colors to be species. I can also do this in the image histogram and see, again, there's my dogs out to the right, but the pounds, it's very clear now that it is my dogs that are skewing the weight. If I'm going to be just looking at the pounds column, the weight of the animals at the shelter is definitely skewed to the right, and those dogs are the culprits. As I'm analyzing this, I could see, whoa, almost all of the other animals weigh less than 5 pounds there in that histogram. I look at that first bin and everything else, all the other colors are there. So it helps you in your analysis to immediately get some answers. We also have image pie chart and image bar chart. Using that same function, just set those colors in the pie and the bar. And sometimes you might want to set colors. Before we had this, actually teachers were asking, can you set the colors? Sometimes you might want to do that in the stress project. If you're doing a personality colors and you wanted to have certain colors be set to the sections, you can write this function to make your different conditions to be a set color, and then you can make your pie chart go to that color or your bar chart go to that color. I'll show you later on how you can use emojis into your bar charts, pie charts if you wish. A little couple of coding notes though that we should take a look at. The students are asked to turn off the condition for the snail in this code and see just what happens. Crude fashion for Bootstrap is, let's discover this. If I put a hashtag in front of snails and turn it off, then I'm going to get this error message down here, and it's very clear. It's like, hey, something wasn't satisfied. As Pirate is going down the list, it says, okay, if it's a dog, do this. If it's a cat, do this. And as it's going through species and it sees snail and it's not told what to do, then Pirate's like, error, what am I to do? Every value for species needs to be told what to do. So we do need to tell it what to do with every value that's in the column that we are writing this conditional function for. And it just says here, if an input has no rule, the function will be undefined for that input and cause an error. This is saying if it's this, which means it's true, then do this. Boolean is already true or false. You just don't have to put equals equals on a Boolean. You could just say are fixed. It's already going to say true or false. So it'll just, if it's true, if it's fixed when it goes down, it'll just make this circle. Else, it'll just make it black. Now, I want to be careful here. You can write an else and not have to put else are unfixed. Make that. I could have written that as well. Had my else if at the end there. You can have else be this catch-all. Sometimes you don't want everything in the data set to come onto your chart. And so if that's the case, you could put else there and you could make your color transparent. Some of my students did that when they had some values that they didn't want to show up. They just made the color transparent. So that's the time that you could use else. That's a possibility for that. But be very careful to not use else all the time, because that would be a chance that you might miss some errors if you've got some things in your data set that you're not catching, because it's just going to come under the else and be thrown there. You could have something get a black circle that shouldn't get a black circle because you had a typo or something in your data set. So be very careful to not just use else all the time without checking your data set carefully. But this does open up strong possibilities, and I'm going to just show you some. The students are asked to go ahead and write their own function that is called young shape. That will make red circle if the animal is young, less than 3, and a blue square if they're 3 or older. And then you get this little graph here that shows them very clearly. Look at that. Those heavier animals are older as well. Well, that kind of makes sense. All of us too, the older we get, the heavier we tend to get to, I guess. But they could, in their analysis, take a look at that. And then here's another one, weight dot, just an example of weight dot. You can make the dots the different sizes based on how much the animal has weighed. And there you can see it, another variable appearing on that image scatter plot. Here's what I want to show you. You could use URLs and emojis, because emoji is just text. So let's talk about URLs first. We have that image URL contract in Pirate, and you could scale it down. Lots of times if you do go use images from the internet, you definitely need to scale them down because they'll be so huge on the scatter plot. So this is scaled down to 0.3 to get them small enough so they don't overtake the scatter plot. Search for things that say clip art so that you could get some nice images to come onto your scatter plots or bar charts or histograms, now that we have all 4 that you can use. And here's an example of the coding there. You've defined these images above in defined images, and now you could just go ahead and use them if the species is dog. put this in instead. That circle that was before, or black square, now use that dog image in its place. And that's how you get that one that you've seen earlier, all of these clip art images of the animals. Here's one a student of mine had done in the cereals data set that we have. They did the different grains as they could find some emojis using the text contract, and they put the color as black, as it doesn't matter what the color is on an emoji, and they set the size of it that they wanted. They put emojis on their scatter plots. Pretty cool. So I just want to show another one here using the bar chart. I guess it's kind of a weird one, but you see what emojis would do. They stretch them. So it kind of depends on how you want to see that used, but there it is on a bar chart, and they kind of get funky, and the same thing will happen on a pie chart. They get a little bit stretched. So it all depends on how you want to use it and what it looks like. But here you can see that the condition was if the sugar was greater than or equal to 10 or less than 10. They used broccoli for healthy and cookies for unhealthy. One last thing I wanted to show you when we talk about how this opens up the analysis. I had a student that was using our cancer data set, and just when the image histogram came about a couple of years ago, it was brand new. She had made this histogram, and this was a mortality rate, taken the number of deaths per state and converted it using build a column to be the mortality rate per state. And I made this histogram of the states of the United States here, their mortality rates, and saw this divide, but didn't really know quite what to do until she hovered over each state to see what was going on. And image histogram came about, and so she wrote this conditional function to put each of the states into regions. And she could see on the right here what happened. She was blown away. Mrs. Straub, come look, look. And here's the regions by color and definite divide by region. Pacific and mountain over here on the left, definite lower mortality rate in the cancer table versus the Atlantic, Midwest, and New England rates. So it opened up her analysis and the things that she had to say about what she found out. So the possibilities are so many if you can get to the writing conditionals and piecewise functions with your students. You'll have a lot of fun doing it, but only because they'll see things like this and get really turned on to data analysis, which is what our goal is for them.